Root functions? That's what we're going to be talking about in today's tutorial. I'm Physics Man from Physics Man Education, and consider this. If we have a quadratic function, we have y as a function of x, where y is equal to ax squared plus bx plus c. What if we wanted to solve this for x? Remember deriving the quadratic formula? This is going to be kind of like that, except we can't cheat with y. We can't just say that y is 0 because we're not trying to find the roots of this function. We're trying to rework this function to find x. So y can still be any arbitrary, variable. So we have to keep it. And we're going to start by dividing the entire equation by a. So y over a is equal to x squared plus b over a times x plus c over a. The next thing we're going to have to do here is we're going to have to complete the square. So we can write y over a is equal to x squared plus b over ax plus, when we complete the square, we take half of this coefficient and square it, so we'll have b over 2a, that's half of the coefficient, and we square it. But we also have to subtract the same value, otherwise we are changing our equation. And of course we still have c over a. Now, this part of the expression can be factored into a perfect square. And this part of the expression is a constant. A big looking constant, but a constant. So we can just move that directly over to the other side of the equation. So on this side we'll have y over a plus b over 2a squared minus c over a. Remember that the signs change when we take them to the other side of the equal sign. And this will be factored into a perfect square. We'll have x plus b over 2a squared. Now we're going to take the square root of both sides. So that's going to look like this. We're going to have x plus b over 2a is equal to square root of y over a plus b over 2a squared minus c over a, and close the square root. Now, there's only one step left in order to finish solving this for x. First of all, we have to consider both the plus and minus of that square root, and then we have to take this over to the other side. So x will equal to minus b over 2a plus or minus this big root. Y over a plus b over 2a squared minus c over a. And there, we're done. We've solved this for x. We can clean it up a little bit like we do with the quadratic formula, where we put these over a common denominator. It's a few extra steps, so I'm not going to do that, although it would look prettier. I'm more interested in the question. Have we expressed x as a function of y? Can we write our bracket y there? And the answer is no. Here's why. This plus minus sign. Remember that if x is a value of y, that means for each individual value of y, we can extract only one value of x. But for each value of y, we're actually getting two values of x. We're getting minus b over 2a plus the square root, or minus b over 2a minus the square root. Now if the square root happens to be 0, that's great. Then we have only one value. But this is really two functions where we could write x1 as a function of y will equal to minus b over 2a plus the square root. And we'll have a second function x2 where we take the minus of the square root. And there you have it. We actually have two root functions from one quadratic function. This makes sense because if you remember the horizontal line test and the vertical line test, a quadratic function will look like a parabola, like this. If this is y and this is x, for any vertical line that you can choose, this function will only cross the vertical line once. Therefore, y can be expressed as a function of x. But for any horizontal line you choose, this function may cross that line more than once. Which means that you can't express x as a function of y, but it turns out in this particular case you can express x as two functions of y, where one function is the plus of the root and the other function is the minus of the root. The way that will look, if we draw an axis like this, there will be one point where they will connect. I'm going to choose this point to be it, and it'll go like that, and it'll go like this. It'll be like this parabola turned sideways, and they'll be symmetric about this point, where this is x and this is y. And there you go. That's a little bit about why we have to deal with square root functions, and a little bit about the difference between this not being a function and these being two separate functions. And that concludes the tutorial. In our next tutorial, we'll do some examples of manipulating these functions, but that'll be in that tutorial. This has been produced by Physics Man Education, and I'm Physics Man. Thank you very much for watching, and I'll see you in the future.
Happy Valentine's Day!
Happy Valentine's Day! Whoa! You're awesome.